Good morning. Today we are going to cover section 9.6, evaluating trigonometric functions. So take the time to copy your title and your essential question. How can we evaluate trigonometric functions with a calculator? Where on the previous lesson, we found them without a calculator. Take the time to write down cofunction identities and draw a simple triangle 3 by 5, and we'll start once you are ready. Go ahead and pause it. So we're going to develop the cofunction identities. We have our triangle. We know that our right angle is always angle C, so we're going to label each of our angles. I'll place angle A up here and angle B down here. Now I'm going to label each of the sides. That is angle A. So therefore, this will be side A. The opposite angle is the opposite side. This is angle B, so therefore side B will be opposite. This is angle C, so therefore this is side C. And now I'm going to find the sine of angle A. Your sine is your opposite over your hypotenuse, just like you learn in geometry. So therefore it'll be opposite is A, hypotenuse is C. Now I'm also going to find the cosine of B, because when I find the cosine of B is your adjacent over your hypotenuse, that'll be A over C again. Since they both are equal to A over C, that means that the sine of A must be equal to the cosine of B. Do you agree? Since they're both equal to A over C, they must be equal to each other. Now, we know that all three angles are equal to, so if I add all three angles, that'll be equal to 180 degrees. Angle C is 90 degrees, since that's a right triangle, so therefore A plus B plus 90 degrees is equal to 180 degrees. Minus 90 on both sides, that will give me A plus B must be equal to 90 degrees. Do you agree? And now the last thing that I'll be doing, I'm going to be solving for B. So therefore I'm going to move my angle A to the right. We can say negative. So therefore angle B must be equal to 90 degrees minus A. And I'm going to take the measurement of B and I'm going to replace it over here. Therefore, since the sine of A is equal to the cosine of B, now the sine of A is equal to the cosine of 90 minus A. -90 degrees minus A. And that's how we get our first cofunction identity. So let A is an acute angle, then the following are true. And we proved the first one to be true. The only difference is that they are using radians and we have degrees. And we can go through a process of improving each of the confunctions. We proved that the sine and cosine are confunctions of each other, that this is true. Cosecant and secant are cofunctions of each other, and tangent and cotangent are cofunctions of each other. And the same goes for cosine of A is equal to the sine of 90 degrees minus A. And we can go through a process of improving each one, but the process will be exactly the same. So let's go through example number 1. Write each expression in terms of its cofunction. So you do need to be able to memorize that sine and cosine are cofunctions of each other. For the first one, I'm going to go through the process and do a quick substitution. So I'm going to substitute. And then from there, for the next ones, we're going to kind of take a little shortcut. But you can always go through this process if you want. So in this case, A is 40. So the cosine of 40 degrees minus A, which is 90, minus A, which is 40 degrees. So I basically just substitute it, but now I'm using degrees. So therefore, the sine of 40 degrees is equal to the cosine of, correct, 50 degrees. And if you type into the calculator, if you have the sine of 40, I want to make sure that I have it on degrees, and I do have it on degrees. So you can go under mode, go down in degrees. If you have your Casio, very similar process. So now I'm going to type in the sine of 40. That gives me 0.642787. And the cosine of 50 is exactly the same. And remember that the reason why. If we do a quick right triangle here, this is the right triangle. If this is 40, that means the other angle has to be 50 degrees. And if you take the sine of 40 degrees, so therefore is your sine is your opposite over your hypotenuse. And if you take the cosine is your adjacent over your hypotenuse. It's exactly the same size that you are using, correct? So for both of them, if you take the sine is your opposite over hypotenuse, if you take the cosine of 50 is your adjacent over hypotenuse, and that's why they're equal to each other. And we can go through the whole process of substitution, or we can just say, cosine and sine are cofunctions of each other. So therefore, 65 plus what gives me 90? 65 plus 25 degrees. And if we want to confirm it, then we can type in the cosine of 65 should be exactly the same as the sine of 25. And they come handy at times on some of the problems that we are going to cover. Tangent of pi over 3. I know that tangent and cotangent are cofunctions of each other. So therefore, pi over 3 plus what will give me 90 degrees, which will be pi over 2. So I'm looking for pi over 3 plus one number will give me pi over 2. So therefore, I'm just going to solve it. So therefore, minus pi over 3 on both sides. So x is equal to pi over 2 minus pi over 3. I'm going to have the same denominator. So multiply by 3. 3 pi over 6 minus 2 pi over 6. So therefore, x equal to pi over 6. So I know that if I add them, they'll be equal to 90 degrees. So go and try example D, E, and F and see what you get. Go and pause it. So in this case, cosine is the cofunction of sine. So therefore, what do I need to add to make it equal to 90 degrees? Well, 52 plus one number gives me 90. That'll be 38 degrees. But in this case, it'll be 37 because that'll give me 89. This is 20 minutes. How many more minutes to get to a degree? Correct, 40. Correct, that'll give you 1. And 89 gives you the 90 that you need. Cotangent is correct. It is the confunction of tangent. So therefore, cotangent pi over 6 plus what number will give me pi over 2? Correct, pi over 3. And the sine of 1. Sine is the confunction of cosine. 1 plus one number will give me pi over 2. Remember that this is not degrees, this is radians. So the only way that we can actually write it down will be just using actually the formula, which will be pi over 2 minus 1. If we want to be able to have an exact answer. Questions? Example number 2. Approximate the value of each expression using a calculator. So we have the cosine of 49 degrees in 12 seconds, in 12 minutes. So I'm going to use my TI-84. One of the things is that we are using degrees, so you want to make sure that your mode is on degrees. It is. And we have it here. So therefore, I'm going to type in the cosine of 49. Because we have a minute, we have to type in a degree symbol. And I'm going to go under angle, second angle. And you see the degree in the minute. So therefore, I'm going to type in degrees, second angle, and 12. I'll go back onto my angle. Notice that it gives you the symbol. Even though it's, did I select the wrong one? Let's see. Yeah, I did select the wrong one. On your Casio, if you're using a Casio, it actually will show us a degree, but it knows that it's a minute. So therefore, this is approximately, I just need two decimal places, 0.65. Cosecant. We know that we can write cosecant as 1 over the sine of 197.9 degrees. So therefore, I need to use my fraction bar, or I can just do 1 divided by the sine, or I can use my second y, my fraction bar, and place 1 over the sine of 197.9. And because I don't have minutes, I don't need the degree sign. So therefore, this is approximately negative 3.25. And the cosine of 30. Now, if cosine of 30, that is incorrect. Why is this incorrect? Correct. There's no degree sign. So therefore, I need to change my calculator mode to radians. So that means that this is in radians. Remember, 3.14 is 180. 6.28 is 360. This is 30. radians. So now I can go back and say in second entry, and now it gives me the correct value for cosine of 30 radians is 0.15. And the last example for today, use a calculator to find the angle in radians. So to be able to find the cosine of theta is equal to 0.89, I need to be able to find the angle whose cosine is 0.89. So therefore, I need it in radians. So I'll make sure that my calculator is in radians, and it is. So therefore, I'm going to use the inverse cosine to find the actual angle. And what we are actually going to be doing is, in order to solve it, to get rid of the cosine, we are going to take the inverse cosine on both sides. That cancels, and that gives me my angle is equal to the inverse cosine of 0.89. And we'll cover inverses in the next lesson. So therefore, your angle is equal to 0.47 radians. If you were working on degrees, if I go back and change it to degrees, that'll be about 27 degrees, correct? One radian is 57, so about half a radian will be, or will be 27 degrees. The sine of an angle is equal to 1.2. So now I'm going to go back into my radians. I can go through the whole process and take the sine inverse on both sides, but most of the time we know that in order to be able to evaluate this, it's going to give me, we're going to have to type in the sine inverse of 1.2. It gives me an error. Did I type it in correctly? It's fine. The go into mode is in radian. So why does it give me an error? Now remember that whenever we graph sine, your sine goes up to 1 and down to -1, up to 1 and down to -1. So that is something that you want to make sure that you are careful when you are graphing sine and cosine. Your domain is up 1 and down 1, correct? If we graph sine, your sine can go all the way up to 1 and all the way down to -1. You cannot find the sine of an angle that's 1.2. That cannot happen. So error, it's sine must be between -1 and 1, including -1 and 1, correct? The tangent of -3.7. So can we find the tangent of this angle? Yes, this is fine, because if you guys remember, your tangent goes something like this. So your range is all real numbers. Where your sine was from -1 to 1, the tangent, so the inverse tangent of -3.7, my angle is about -1.3. And if I want it on degrees, I can go back into mode degrees. Remember, it's negative 1.3, so it should be about close to 90 degrees. Do you agree? So it's 74. Negative 74 degrees. Not as close as I thought. Now, how do I find the cosecant theta? Now, we are very tempted to do the following. We're very tempted to do theta is equal to cosecant inverse. But notice that your calculator does not have a cosecant. So in order to be able to calculate the cosecant, we must do as follows. And we're going to do that only for the first problem, and then on the second one, we'll take a small shortcut. First, I'm going to rewrite cosecant. I know that is 1 over the sine of theta. Do you agree? I want to multiply both sides by sine of theta. So therefore, 1 is equal to negative 3.72 sine of theta. I'm going to divide both sides by negative 3.72. So therefore, the sine of theta is equal to negative 1 over 3.72. And now I can take the inverse. So I can take my inverse on both sides, the sine inverse. The sine cancels with the inverse, so therefore theta is equal to the sine inverse of 1 over negative 3.72. And this is how we need to type into the calculator. And so sometimes if you forget how to do so you can just kind of develop your process to remember how to type in the inverse sine. I'm going to use my fraction bar of 1 over negative 3.72. And that is in degrees. Let me go back and change to radians. In calculus, you're going to be using mostly radians. So therefore, that gives me my angle is approximately negative 0.27. So I can go through the entire process every single time, or I can say theta is equal to the cosine of 1 over 0.72 inverse. Or you can develop the process as we did on B. So therefore, inverse cosine of my fraction 1 over 0.72. And it's error. Did I mess up again? Let's see, mode. It's on mode. On radians is fine. So why is it giving me an error? Well, two things, right? If we remember our graph for secant and cosecant, what is your range? So your range for secant and cosecant, if I can quickly find my notes. We know that there is an undefined. Correct? So your range, it's only from negative infinity to negative 1, and from 1 to positive infinity. So therefore, you cannot take the cosecant of a number that's between negative 1 and 1. This is undefined. Or if you think about the cosine, 1 divided by 0.72, you cannot take the cosine of an angle cannot be bigger than 1 or smaller than negative 1. How about cotangent? We can go through a process just like we did on letter D, or we can just say it's going to be the inverse, but it has to be 1 over 2.5. And that one should be fine, right? Because cotangent and tangent, it's all real numbers for the range. So therefore, tangent, my fraction bar, 1 over 2.5. I can just do the inverse tangent 1 over 2.5, which is a little faster. So this will conclude the lesson for today. Have a great day, and I'll see you next time.